So in this video, we're going to introduce the concept of Monte Carlo simulation. So its use is mostly in finance, where you make use of computer software to represent the operation of a complex financial system. You want to generate a large number of random samples from a specified probability distribution or distributions to represent the role of risk in the system. So it's used to compute the risk and return of an investment. Okay, so at the end of the day, you want to simulate the portfolio's profit and loss performance for a specified time horizon. You can have repeated trials within the simulation, that is, each trial involving a draw of random observations from a probability distribution, producing a simulated frequency distribution of portfolio returns from which performance and risk measures are derived. So it's an important use of Monte Carlo simulation in investment is that it is used as a tool for valuing complex securities with no analytic pricing formula. For example, we want to use it to value a contingent claim. Okay, so for which there is no analytic pricing formula available. Okay, so for example, I want to value a contingent claim having a value at maturity equal to the difference between the underlying stock price and the average stock price during the life of a contingent claim, or $0, whichever is greater. So I'm just taking the case of a contingent claim here, where the value is equal to stock price minus average stock price so this notation is similar as being you take the stock price minus average stock price. This notation is similar to this one. Okay. All right. Okay, so that is a contingent claim payoff diagram. All right. So let me just name you the steps in a Monte Carlo simulation. What are the steps that you are going to have that you should follow to implement the Monte Carlo simulation? So first of all, we want to specify. Okay, So when you want to simulate the Monte Carlo, there are many steps, but there are two processes. First process is you want to specify the simulation. And the second one is you want to run the simulation over the specified number of trials. So under the specification of a simulation, you want to specify the quantity of interest. So I just took the example of the value of a contingent claim in here. Second is you want to specify a time grid. You specify a time grid. Okay, case subperiods with delta t increment for full time horizon. Okay, subperiods delta t increments. Good. You want to specify the distributional assumptions of the key risk factors. Distributional assumptions of key risk factors. That was for the specification of the simulation. Now, for the process of running the simulation over the specified number of trials, we reach at step 4. You want to draw a standard normal distribution. No. You want to draw a standard normal random numbers. Random numbers for each key risk factor over each of the case subperiods. Fifth one is you convert the standard random numbers to stock prices. Average stock price and other relevant risk factors. The sixth one is you calculate the value and present value of contingent claim payoff. I'm going to write contingent like this as the short form. And the last one is just to repeat all the above steps and to calculate a summarized value. Okay, the mechanics of the implementation. can be as follows. When we want to quantify the interest in terms of underlying variables, okay, here we've taken a contingent claim being our interest. So we want to have the stock price, and we want to also specify the starting value of the underlying variable. Okay, and then we talk of the grid, and that is the horizon in terms of calendar time, split into a number of sub-periods. We've taken k in total, with delta t being the time increment. Okay, and then we have the distributional assumptions for key risk factors driving the underlying variables. Okay. Fourth is we use a computer program or spreadsheet function. So this can be done easily in Excel, where you generate a normal random distribution after the sequence of simulation step. Okay. And you want to convert the standard normal random numbers into stock prices. Okay. And you compute the value of a contingent claim using the appropriate interest rate as of today when you are discounting to the present value. And then you just repeat, you just carry out a series of iterations, a series of repetitions to reach a calculated summarized value. So as a summary here, I'm going to write a little summary for the Monte Carlo simulation. Monte Carlo simulation involves the use of a computer to represent the operation of a complex financial system Okay. A characteristic. I use a short form of characteristics as AR feature of Monte Carlo simulation is the generation of large number of random samples from specified probability distributions to represent the operation of risk in the system. So what's the use of Monte Carlo simulation? It is used in planning, in financial risk management, in valuing complex securities. It is a complement to analytical methods, but only provides statistical estimates and not exact results. So that was the theory of Monte Carlo simulation. Thank you for your attention. Don't forget to hit the like button, share this video, and subscribe to my channel. If I have time, I will make a practical on Monte Carlo simulation in Excel.